Now let's go through a demo on interrupt preemption. So this is a diagram that we had seen previously. And this talks about when a lower priority interrupt is preempted by a higher priority interrupt. The lower priority interrupt stops its execution, and the higher priority interrupt completes execution, and then the lower priority interrupt resumes from where it stopped, and then the original thread is resumed. Now we will see two scenarios, that is lower priority interrupt which is already active, which is preempted by a higher priority interrupt, and a higher priority interrupt already active, which is not exactly preempted, but a lower priority interrupt comes in at that time. So we will see both the scenarios. And the interrupts that we are going to use are the SysTick interrupt and EXTI0. That is the user button that we have, but we will invoke the interrupt in software, and we will discuss about why we are doing it that way and why we are not pressing the button and invoking the interrupt. I'll be sketching a few things here. So we have the SysTick handler and the EXTI handler. So the EXTI handler is nothing but the user button, and if the user button is pressed, an interrupt is invoked, and that actually does something to the LEDs on the board, which we'll see later. As of now, just consider these two as two interrupts, and we will just see the interaction between these two interrupts. We are not concerned about what these interrupts do right now. We are just concerned about the preemption behavior of these interrupts. And so this is the SysTick interrupt. So say the SysTick interrupt comes in like this, and the SysTick interrupt is a lower priority interrupt than say the EXTI0, that is the external interrupt 0. Say it is a lower priority interrupt. So when the SysTick interrupt comes in, say the interrupt ISR starts getting executed like this here. Assuming this is lower, now this is lower and this is higher. The interrupt starts getting executed, and then the EXTI pulse comes in here. When the EXTI pulse comes in here, this interrupt is stopped and the EXTI gets executed completely, and then the SysTick is resumed. Okay. Similarly, if this is EXTI0, now suppose this is EXTI0 and this is SysTick, the same thing happens. This is say EXTI0 and this is SysTick. Now EXTI0 has a lower priority and SysTick has a higher priority. Exactly the opposite happens. Now to see it in action is a little bit tricky. So we'll be setting breakpoints at strategic places in the code, and we'll then follow the code and we'll try to see how this behaves. So follow along and rewind, repeat, watch this video multiple times if you do not understand. And I would say that for especially all the coding videos that we are doing, you might need to watch them multiple times, and then you're free to ask your questions as well if you have any doubts, and we'll try to solve it. So let's see. So this is the logic. So how do we realize that? So what we'll need to do here is we'll use the SysTick handler as the base. So at any cost, we will have the control come and get stuck in the SysTick handler like we were doing previously. So we will have the control come into the SysTick handler. Now within the SysTick handler, we are going to trigger the EXTI0. This is not INTI0, this is EXTI0. So we'll trigger the EXTI0 through software. We can trigger it through the button also, but we will trigger it through the software for the simple reason that within the duration of the SysTick handler being executed, this interrupt has to come in. EXTI0 has to come in. Or within one, the other one has to come in. So if this is SysTick and this is EXTI0, like previously, it has to come in within this time. And it is very difficult to keep the timing if we are if we are not careful, and it is very difficult to do physically, that is pressing the button exactly at the time when you have the cystic handler active. So this is the best way to activate or set the pending status of the EXTI0. So here, not only are you learning about the interrupt priority, but you're also learning about how to set an interrupt through, how to set the pending status of an interrupt through software. So pressing the button and setting the pending status of the interrupt this way, setting the value in the IPSR register, has the same effect. That is, it sets the pending bit of that interrupt. So the pending bit could be set by either the button or this. Okay. So let's discuss about the expected behavior. So expected behavior, assuming that the first scenario is the EXTI0, the priority is higher for EXTI0. So how do you see that? So when you will be trying out this code on your end, what you need to do is to come up to here, so your breakpoint will hit here, and then single step into this line. Now remember that EXTI0 priority is higher in the first case. Then again, after you single step into this line, give it a free run, do a continue. When you do a continue, this is considered the IRQ run, right? So cystic, this is the complete cystic run, which is this function. Whatever are the contents of this function is the complete cystic run. We will see that even before reaching this line, it will go into the int I0 handler. Okay. So again, this naming is wrong. It is EXTI0 handler. Okay. So we will change it, but this is what it is. So it is EXTI0 handler. It comes in here, even before coming to this line. Now, if it was the other way around, that the cystic handler priority was higher than EXTI0 handler. Sorry, read it EXTI0 handler. So if the priority was higher, what we would see is we'll come to this line. Then if you do a free run, it will come and get stuck in the ASM, this line, because that is the time when cystic handler is of a higher priority. So even if the pending bit is set, that interrupt will not preempt the cystic handler. Only when you move out of it, if you do a continue from here, will it come and hit the EXTI0 handler. Okay. So that is what is going to happen. Okay, so let's check what are the priorities. So the first time we need to have INTI0 or EXTI0 handler to have a higher priority, and that we do in the function where we enable cystic and where we configure INTI port A0. So this is again EXTI0. Okay. If you have questions about INTI and EXTI, we can just have a look here. These are all EXTI. You can see EXTI, EXTI, EXTI. These are all EXTI. So yeah, that was an oversight from my part. Sorry about that. But I hope you get the idea. So configure EXTI0, port A0. So in this configuration, this is where you're setting the priority of the interrupt. Okay, and we are using all the 4 fields to set the priority. We don't have any sub priority at this point. It is default, all the 4 upper bits in the interrupt priority register to define the priority. So this has a priority of 3. And let's see what cystic has. Cystic has a priority of 4. So clearly the EXTI interrupt, or INTI0 as I have written, is of a higher priority here. Check this out again. So you've set a higher priority in the, and we have gone through the interrupt priority register, if you remember. So we have set the interrupt priority there. Okay. So cystic priority, this is where you're actually SHP. So remember, we talked about the priority being set in different places in the memory, but these priorities interact. So that is what is happening here. So SHP, in SHP 11 you set the cystic priority, but then for this one for the port A0, you set the priority in interrupt priority IP register in NBIC, but they interact. Okay, so let's put it to debug first. Okay, so we have put this to debug like before, as you have seen. Now let's come up to here. We set a breakpoint here. Next, continue should, let's do it through here. It's fun doing it through the debugger. So we are in the SysTick handler. So we are in the toggle LED. Okay, so let's step into this, not into the place where we are setting the EXTI0 through software. Okay, this is equivalent to pressing the user button at the exact time when this interrupt is active. That is what is happening here. That is the action we are trying to mimic here. So let's step into, or rather step over this. So we are here now. Okay, now this is very important. Now see the next step. What happens when I continue? Since this priority is higher, it will leave this interrupt and come here, jump here. Okay, let's see that. When I do continue, did you see that? It came here. Okay, so it came here, and then if we do a continue, then it will come here and get stuck. See that? So when I did a continue, it completed the INT0 handler, and then it came back to the SysTick handler to the line where it was, next line from this one. So it executed this interrupt and then it came back. Why? Because INTI or EXTI0 handler is of a higher priority than SysTick handler. Now let's make the SysTick handler of a higher priority than the EXTI0 handler. Okay, so we'll make the priority higher here. Let's see. So this is, say this is priority 4, and of course lower number is higher priority, we know that. So priority 4, and this was priority 3. Let's make it priority 5. And for you can try out what happens when you put the same priority for both the interrupts. Okay? And we discussed that as well. Find out what happens when you set the same priority for both the interrupts. So now INTI0 has or EXTI0 has a lower priority than SysTick. Okay. Now the behavior will change. So let's see what happens. Let's start the debug session again so that it recompiles, because we've changed the priorities of the interrupt, so it needs to recompile. Okay. Now let's again continue here. Okay. Continue once again, and we are in the SysTick handler. Now you'll see the difference in the behavior. So we've come to this line now. So this will set the pending status. What did we see last time? When we did a free run from here, it went into this handler and then came back to ASM. This time the behavior is going to be opposite. Did you see that? It did not jump to this interrupt handler now. It came to the next line here, because now INTI0 handler is of a lower priority. But then this is the pending status has already been set. So when it leaves the SysTick handler, it has to execute the INTI0 handler, right? So let's do a continue and see where it comes. So do a continue. The moment you do a continue, you see that it has come into this handler. So did you see the difference here? It executed this interrupt completely and then it came into this handler to work on this handler. So we saw two scenarios. That is when the interrupt that comes while an interrupt is already active can preempt or can wait, depending on the priority of the interrupt. If the priority is lower, then it has to wait for the higher priority interrupt to complete before it can execute. And in the other case, we saw that the interrupt was executed immediately, and then it went back to that handler.